Hello students, my name is Shesi George, your professional accounting teacher. Before you continue with this video, please subscribe to my YouTube channel. Thank you. Alright, let's get started. In this video, we are going to continue with the concept of simulation. So before you continue, please watch the last video on simulation 1. Alright, so I explained that when, for example, you have the original system, this is a system of operation. A system of operation. It could be inventory control, okay? It could be production control. All right, the original system. This is a real system or the original. And you decide to copy the system using a model, using a mathematical model to carry out an experiment. By carrying out an experiment, all right, to form the original, to duplicate the original, So this is a model, all right. So using a concept known as Monte Carlo simulation technique. So Monte Carlo is an experiment on chance that uses random numbers. Okay, it uses random numbers and requires decision making under certainty. So that is about Monte Carlo. So in the last video, I demonstrated a simple question. Then I told you that we have two steps. Number one is to calculate the cumulative probabilities and the random intervals. Okay, you will use the cumulative probabilities to determine the random interval. That's the first table. Then the second table is the solution table. So the solution table depends on, that's the solution table. It depends on what you are asked to simulate, that is to copy, using Monte Carlo. All right. So these are the two basic steps, as simple as that. So let us look at this question to demonstrate that. Please, before you go on, try to watch simulation 1. All right, with a simple illustration. All right. So let's get started. Looking at this question. All right. The previous data from the queuing system gives the following pattern of internal arrival duration and service duration with the accompanying probabilities. Okay, so the two tables have been given: the internal time, minutes, the probabilities, minutes, then the probabilities. So this is the time. Then by using the following random numbers for arrival and these random numbers for service time, you are required to simulate the queue behavior for a period of 60 minutes. Then estimate the following, assuming service starts by 11. So let's first do the simulation of the time, all right, for 60 minutes. So the first thing to do to determine the cumulative probability and the random interval for each operation, okay, for each event, we have the arrival. So you have the arrival time. Okay, so for the internal arrival time, we have minutes, and the minutes we have 1. All right, which is 1, 3, 5, and 7. For the service time, we have 1, 3, 5, and 7, the same. Then the probabilities are different. Okay, so we have 1, 3, 5, 7, and 9. Then the probabilities is given. So we have a 0 to 0.25, 0.30, 0.14, 0.111. All right. Then, like I said, you compute the cumulative probabilities. So the cum probabilities, we have 0.2. When you add 0.2, you add to this, it will be 0.45. Add to this, we have a 0.75. If you add this to this, all right, what do you have? 0.89, and this will give you 0.100. Okay, then the next thing is the random interval. So the random interval, okay, like I told you, you start from 0 to the number before 0.2. That is, this is 20, is 19. The number before 45, so you just bring this 20, all right, is 44. Then bring this 45 to the next 45. To the number before 75 is nothing but 74. Then you bring down your 75. The number before 89 is 88. Bring down your 89. Then, of course, 100 is 90. Okay, so that is for arrival time. Then we do for service time. Service. So for service time, so for the service time, you add this to this. What do you have? 0.40. Then you add this to this. You have add this to this, 0.70. When you add this to this, you have a 0.88. And lastly, if you add, you have 1.00. Then you form your random interval. The number before 19 is 1 to 18. You bring down your 19. What do you have? Before 40, that is 39. That is right, 40. Before 70 is 69. Bring down your 70 to 87. Then 88, of course, to 99. All right, so now the next thing to do, the next thing is the solution table. So for the solution table, you first ask yourself, we are to simulate, according to the question, we are to simulate the queue behavior. All right, the queue behavior has to do with the arrival time as the customers are arriving. So let's start with the arrival time. So we have our solution, the solution table. Okay, all right. So we have the solution table. Okay, so for the solution table, let's start with the random numbers. Okay, for the arrival time, it has been given separately, which is 32, 37 to 47. Okay, then for the service time also is given. All right, so we have 32, 37, 60, 70, 78, 61, 63. We have a 53. Then we have 33, and lastly 47. So let us start to simulate using the arrival time. So to use the arrival time, of course, this is simulated arrival time. Simulated arrival time. So the simulated arrival time, so for 32, then you go to the random interval. The random interval, you look at where 32 falls to. So 32 falls within this interval. Okay, so it means the first person arrived 3 minutes after 11. That's 3 minutes. So this is in minutes. Okay. Then 37 falls still within this, and the corresponding minute is 3. All right. So we have 3. 60 falls within this interval, 60, and the corresponding minutes. What's the corresponding minutes? Is nothing but 5. The corresponding minutes. So we come here, 5. So we are using this random interval. That's the Monte Carlo step. This random interval to simulate, that is to duplicate the original system. To duplicate the original system. Okay? So for 70 falls within this interval, and it's the corresponding minutes is 5. So for 70 is 5. For 78, so we look at 78. Okay, for 78, and it falls within this interval, and the corresponding minutes is 7. All right, so that is 7. For 61, of course, it falls within this interval, and that is 5. For 63 is also 5. For 53, of course, 53 falls there, and the corresponding is 5. It's 5. For 33, so 33 falls within this interval, and the corresponding minute is 3. Then for 47, okay, for 47, the corresponding minutes for 47 falls within this interval, and something is 5. Okay, class. So we have been able to simulate for 10 customers. Okay, so if you count, it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the service time. Let us simulate for service time that has different random number. So we have random number, then we have simulated service time. Okay, then the random numbers for is 63. The second one is 26. The second one is 02. 74, that's the 99. The next one is 08. The next one is 84. The next one is 48. The next is 25. The next number is 93. And the last number is 68. So we do our simulation. Then to do for 63, go to the random numbers. 63 falls within this range, and the corresponding minute is 5. So we have 5. Then for 26 falls within this range. The corresponding number is 3, and that is 3. So we are using Monte Carlo. Monte Carlo uses random numbers, okay, and a set of probabilities to copy the original system. So we are copying the original system. This is the original system. We are duplicating the original system. Okay, this is the model. Now 02 falls within this, and this is 1. So if we continue, you have 9. If you continue, we have 1. We have 7, 5. Then we have 3. For 93, that falls within this place, is 9. Then for 68 fall within this. For 68, which is the last one, fall, and that is 5 for 68, and the corresponding is 5. All right. Okay, class. Now with this simulated time, we can calculate our average queue length. All right, the average queue length can be calculated. Okay, So that's the B part of the question. The B part of the question. So estimate, assuming the average queue length, average waiting time, average service idle time, average service time, time a customer spent in the system, then probability of being in the system. So let's go into that. Now let's determine the arrival time. So for the arrival time, the assumption is that the time the business opens is assumed to be 11. The service starts by 11, but the first customer arrived at 3 minutes after 11. So we have that is 11:03. The second customer arrives in 3 minutes time after this, and that is 11:06. The next customer, all right, arrives in 5 minutes after the second person, and that is 11:11. Okay, 11:11. The next customer arrives in 5 minutes time, and that is 11:16. If the next customer arrives 7 minutes after this customer, and that is 11:25. Okay, 11:23 rather. Sorry for that. 11:23. If the next customers arrive, which is 5, that is 11:28. If the next customer arrives, we have 5 plus this, we have 33. Okay. If the next customer arrives 5 minutes after, that is, it must have arrived 11:38. The next customer would have arrived 11:41, and the last customer will arrive 11:46. All right. Now let's look at the start time. Of course, the first customer starts by service will start as he arrives. That's the assumption. Okay, 11:03, and it will, if you look at the service time, simulated service time is 5. It means the service time, then the service will end 5 minutes after, that is 11:08. Before this 11:08, a customer has already arrived. All right, and this comes after, earlier. He has arrived earlier, but the service will start when the first customer ends, so which is 11:08. So the second customer will start 11:08, not when he arrives. Though he arrives 11:06, but the service starts 11:08. Then he spent 3 minutes. Of course, he will stop the service by 11:11. All right. Now, as at then, the third customer has arrived. The third customers have arrived, and the service stop the same time. So we start the same time, and he spent 1 minute. That is 11:12. So as at that time, the customer has not arrived. The next customer arrived 11:16. The service stopped 11:12. So, but this service will start 11:16, and it spent 9 minutes. So 9 plus 16, that is 11. So if you spend 9 minutes, so that is, it will stop 11:25. As at that time, before this time, a customer has arrived, but it cannot be attended to. It will be attended to when the current customer finishes, and he finished 11:25. So the service will start 11:25. Okay, and he spends 1 minute. So this is 11. If he spends 1 minute, This is 11:26. Okay, so the next customer arrived 2 minutes after this. The current service stops. The current service ends to 11:26, but this man arrived 11:28. Therefore, he will start his own when he arrives 11:28, and he spends 7 minutes. So if he spends 7 minutes, he will have stopped 11:35. So if you stop in 11:35, the next customer before this 11:35, a customer is already waiting that arrived in 11:33, which means the next customer is waiting, but he will start exactly when this one ends. Okay, 11:35, and he spends 5 minutes, so which is 11:40. Okay, if he starts, don't forget, a customer is already waiting, but the customer will start when the current customer ends the service. It will not be attended to until 11:40. All right, until 11:40. Okay, and it spends how many minutes? 3 minutes. So this is 11. It must have ended by 11:43. So 11:43. Before 11:43, a customer is already waiting that arrived 11:41. So he will wait till 11:43. That's the queue. A customer will be on the queue. Okay, and he spends 9 minutes. So if he spends 9 minutes, he will finish 11:52. So 11:52, as at that time, a customer is already waiting, is on the queue that arrived 11:46. So by 11:46, service is still going on. So you have to wait till 11:52, and that customer, the last customer, spends 5 minutes. So when you add 5 minutes, the service ends 11:57. So it means that all the customers spent 57 minutes in the service. That's what it means. Now let us calculate our waiting time. Let's determine our waiting time. The waiting time for the attendance and for customer. The waiting time for attendance and for the customer. So this is customer, this is attendance. Now, service starts by waiting time. Don't forget waiting time. The service, the business opens by 11 o'clock. So it means the attendance would have waited for 3 minutes while there is no customer as at this time, because the customer arrived 11:03. Okay, class, don't forget. Now if you look at this, as at this time, okay, a customer has already arrived before the end of this service. When the service starts, a customer is already waiting, and he waited for how many minutes? He arrived 11:06. The service starts 11:08, so he waited for 2 minutes, but there is no. Then line in length in queue. The line in queue, or the line in length or queue, which means that as at this time there is one customer waiting that spends 2 minutes before is attended to. Okay, no customer is waiting here. It was even the attendance that is waiting. He waited for 3 minutes. The customer came 3 minutes after 11. So nobody in queue, no customer in queue. Okay, class. Then the next one is that if you look at this, a customer arrival time is 11. So as at that time, the service ends exactly that time the customer arrives. So neither the attendance is waiting nor the customer. No time. All right. Even there is nobody on queue because the man arrived, the next customer arrived exactly that time it ends. So then he spent 1 minute, which is 11:12. Then as at that time, no customer. When the next customer came, it came how many minutes after? That's about 4 minutes. 4 minutes. He arrived at 11:16, and before then, the service has already ended for the previous customer. He has gone. So the attendants waited for 4 minutes. No customer is waiting. Nobody is in queue. Then the service ended 11:25. Then a customer is already waiting. That customer waited for 2 minutes. So 25 minus 3, that's 2 minutes. So no attendant did not wait, but the customer waited for 2 minutes. It means one is waiting in line. There is a queue. Okay? See the way I'm taking this step by step. Then, of course, I want you to tell me this. The service ends 11:26. No customer. The next customer came 11:28. Who is waiting? Of course, it's the attendants. The attendants waited for 2 minutes. No customer is waiting. Nobody in queue. Then the service ends 11:35. Before 11:35, a customer has already arrived that waited for 2 minutes. Customer waited for 2 minutes, one person in queue. And the service took 5 minutes. Before 11:40, another customer is already waiting. The customer came 11:38. All right? 11:38, it means the attendants did not wait. The customer waited for 2 minutes. It means one person is in queue. And he spent just 3 minutes. So before this 11:43, a customer is already waiting. And he waited for 2 minutes. The attendants did not wait. The customer waited for 2 minutes. And one person in queue. Then, before this time, a customer has already arrived. The last customer. He arrived at 11:46. Which means that he waited for about 6 minutes before he's been attended to. Okay? He waited for 6 minutes. 6 minutes. It means 1. Alright. Okay? Hope you understand this. So you can go through again with the video. Now, we are asked to calculate average arrival time. The average arrival time is to add this and divide by 10. Alright? Average service time. If you have to add the average service time, add all this number, divide by 10. Okay? Average waiting time, attendance waiting time, add this. Okay? Divide by 10. Average customer waiting time, of course, you add this. So let us do that. Then average customer in the system. Average customer in the system. So you add this, or average queue, length in queue. Just add this divided by 6. Okay. All right. So the average queue length is You add, and this is 1, 2, 3, 4, 5, 6. That's the queue length. That's 6 divided by number of customers, which is 10, and that is 0.6, which is approximately to 1 customer. That's the average queue length, 1 customer. All right. Then we have average waiting time. Average waiting time. Okay, average waiting time is customer waiting. That's average, and that is total waiting time of customer before the service. So before the service is to add 2 plus 2 plus 2 plus 2 plus 2. That's 10 plus 6. That's 16. So that one will give us 16 divided by 10. That is 1.6 minutes. That is the average waiting time of customers. All right. The average queue length is total line length divided by number of customers, and that will give us 6. So when you add, okay, when you add 1 plus 1 plus 1 plus 1 plus 1 plus 1, this will give you 6. This is average customer. That's waiting time, which is 1.6 minutes divided by number of customers. Then if you want to calculate idle time is the time the attendance is waiting for customer. He is waiting, he's not doing anything. Okay, we have 3 plus 4 plus 2. That is average service idle time. Average service idle time will be 3 plus 4 plus 2. 3 plus 4 plus 2, and all over average, all over 10. Number of customers, which is 10, and that is 9. 3 plus 4, 7 plus, that's 9 over 10, which is 0.9 minutes. That is average idle time. It is the time the attendance is waiting before the service. Add together, divide by 10. Okay. Then average service time. When you add the service time, it gives 48. When you add this is the service time, 48. Okay. Then you divide by 10. So average service time. Average service time is 48 all over 10, which is 4.8 minutes. 4.8 minutes. All right. 4.8 minutes. Okay, class. All right. Then the average time customers spend in the system. The average time a customer spend in the system. So this is the service time plus the average waiting time. That is the time customers spend in the system. So just add these two together. It will now be 4.8 plus 1.6. So this is the average time, average service time plus the waiting time. That's when you add these two together, it's going to give you 6.4 minutes. 6.4 what? Minutes. So this is average time spent in the system. Average time spent in the system. Okay. So if you love this video, please do share with your friends. Thank you. Bye for now.